Assalamu alaikum dear students. In this video we'll see some more concepts and definition on sets. If you want to see the introduction part of sets part 1 video, you can just click that I button. Now we'll get into the topic. In last class we stopped at the representation of sets. You can represent sets in two forms, roster form and set builder form. And I gave one or two examples. If you feel that you want me to give some more examples in roster form and set builder form, you can comment in the comment section below. Now we'll get into the next topic. So today's topic is cardinality of a set. Cardinality of a set. Cardinality of a set. It is also called as cardinality of a set or cardinal number of a set. Okay. Now let me take a cover. Let me take a cover A. Right. Now in this cover I'm just putting some 5 chocolates in it. That dairy milk, one more dairy milk, 2 dairy milk chocolates, 1 Milky Bar chocolate, 1 Oreo chocolate and 1 Kit Kat chocolate. So in this cover A, I kept put 5 chocolates in it. Right. Now, if you ask some of your friends, what they'll tell you, how many elements are there in this collection? 1, 2, 3, 4, 5. Right. So if we count like that, you will get 5 only. But according to the concepts of sets, the number of when we write this as a set. First of all, this collection is a set or not? Yes, this collection is a set because we can clearly tell which element belongs to this collection and which element does not belong to this collection. Right. Now, if we write the set in roster form, this is an important condition. Please listen. The dairy milk chocolate is present twice in this cover, but when we write it in roster form, we will not write it 2 times. We will write it only 1 time according to set concept. Right. Now, dairy milk 1 time, then Milky Bar, then Oreo, then Kit Kat. So number of elements in the set is how many? 1, 2, 3, 4. So number of elements of the set A is nothing but 4. We will not write it as 5. Why? Because when we write according to set concept, when we write a set in roster form, even though the element is present twice in the cover or in the back, we will write it only once. So the number of elements is not 5. The number of elements of the set A is 4. So this is called the cardinality of the set A or cardinal number of the set A. So this is the cardinality of the set. So now we'll get into the next topic, which is related to the cardinality of the set. Now we will see 3 concepts which is related to the concept of cardinality. Right. That is, the first concept is empty set. Empty set. A set is said to be empty when if it has no elements. If it has no elements in it, then we can call that set as empty set. So if A equal to, how will you write empty set? Just you can write like this. You can start the brace and end the brace without putting any element inside. So, or you can write like this also. You can use this Greek alphabet 5. You can use this Greek alphabet 5. Right. This A is a null set. Either I can represent null set like this or like this. But some students, what they do, they used to write like this, which is wrong. This is not a null set. Okay. Yes, this is completely different. This we will see after we will get into the exercise sums. You will know what is this. Okay. So either I must use this or this for empty set, not both together. Okay. This is different. Okay. Now getting into the next content. Yes, if A is an empty, if A does not have any elements in it, then I can tell that A is an empty set. A is an empty set. Is it clear? Now if A is an empty set, what is the cardinality of the set A? Cardinality of the set will be 0, no elements, right? So n of A will be 0. So, and if n of A is 0, then I can tell that A is an empty set. Now the next concept is finite set. This is also related to the cardinality of the set only. Okay. So finite set. When a set is said to be finite set, if the number of elements in a set is a definite number. The number of elements in a set is a definite number. Right. So let me tell you, if A equal to 1, 2, 3, 4, dot up to 1 lakh. Up to 1 lakh. Now is this set a finite set or infinite set? What is n of A for this? 1 lakh, right? N of A is nothing but 1 lakh, right? So is this a finite set or infinite set? It is a finite set. Even though the number is large, huge number also, it is a definite number, right? So if the number of say elements in a set is a definite number, then it is a finite set, even though the number is a huge number, even though it is 1 lakh or 1 crore or 1 billion or 1 million, 1 trillion, whatever it is. If the number, you can tell that this number of elements are there in this particular set, or we can tell like this: if the number of elements in the set is a definite number, then it is a finite set, right? So the next is infinite set, the opposite of this, the negation of this, right? So when a set is said to be infinite, just an opposite of it. If the number of elements in a set is not a definite number, it's not a definite number, we don't know how many number of elements are there, we don't know how many number of elements present in that set, then only we call it as an infinite set, right? For example, can you what are the examples that we can give for infinite set? We can give set of all natural numbers, set of all natural numbers, set of all whole numbers, right? If the number of elements in a set is not a definite number, that is set of all natural numbers. Or natural number starts from 1, 2, 3, 4. We don't know where it ends itself, yes or no? We don't know where the natural number system ends, right? So the number of elements in this is, it is not a definite number. We don't know how many number of elements are there. It goes on and on. Yes, right. So natural number set is also an infinite set. Set of all whole numbers. Whole number set. This is also, it starts from 0, 1, 2, 3 and it goes on. We don't know where it ends, right? So the number of elements in this set also, it is not a definite number. So this is also an infinite set. Example of an infinite set. Set of all integers. Set of all rational numbers. Set of all real numbers. All these are some examples of infinite set where we don't know number of elements in it, number of elements in that particular set, right? Now we'll get into the next topic. So we have seen 4 things today: cardinality of a set, empty set, find what is a finite set, and what is an infinite set. Now we'll get into the next topic. The next topic is nothing but equal sets. When we can tell 2 sets are equal. Let me take if A equal to 1, 2, 3. B equal to 1, 2, 3. Yes. Now we can clearly tell that what are the elements of A? 1, 2, 3. The elements of B is also 1, 2, 3. Clearly you can tell that if A and B has the same elements, then I can tell that set A is equal to set B. Okay. In order to understand more clearly without any confusion, let me give you one more example. If A equal to 7, 9, 11 and B equal to 11, 7, 9. Now these 2 sets equal? Yes, these 2 sets are equal. Only thing, the order has been changed. If the order is changed also, if both sets have the same elements, then they are said to be equal. Because the elements of A are 7, 9, 11. The elements of B also, it is 7, 9, 11 only, but it is the order is being changed. In that case, if the order is changed also, the set if the number are the same, if the set has the same set of elements, then we can tell that the 2 sets are equal. Is it clear? Right? Now we'll get into the next topic now. So the next concept, the next topic is subset of a set. Subset of a set. Let me take a set now. A equal to 1, 2, 3, 4, 5. Right? Now a set B is said to be a subset of A if all the elements of B is also an element of A. B is a subset of A if all the elements of B is also an element of A. Let me give you an example and explain. Let me take like this: 2, 3, 5. Now, whether B is a subset of A or not, we'll check it. All the elements, what is the condition? What is the definition given in the textbook? All the elements of B must also be an element of A. So let me start with the first element. 2 is an element in B. Also 2 is an element of A as well. 3 is an element of B. Also 3 is an element of A. 5 is an element of B. Also 5 is an element of A. So all the 3 elements of B is also an element of A. So I can tell that B is a subset of A. B is a subset of A. B, right? How will I write in notation form? I can write like this: B is a subset of A. I will use this symbol. Okay. So B is a subset of A in this case. So let me give a non-example so that you will understand more clearly. Right? Let me take if B equal to 2, 5, 9. So let me take the same definition itself. 2 belongs to B. Also 2 belongs to A, 5 belongs to B, 5 belongs to, also 5 belongs to A, 9 belongs to B. But what about 9? Does it belongs to A? No, 9 is not there in A, right? So even one element does not satisfy the condition, right? Yes or no? One element doesn't satisfy the condition. Therefore, what I can conclude? Therefore, B is not a subset. B is not a subset of A. B is not a subset of A. How will you write in words? I'll write like this. B is not a subset of A. Right. We have some more definitions and concept that has to be seen. I'll just stop the class with one question. If you know the answer, you can. If you know the answer for this question, you can comment in the comment section below. And the question is, as I told you about infinite set, set of all natural number is also an infinite set. Set of all real number is also an infinite set. Now, but there is some difference between these two. So my question is, what is the difference between these two? Both are infinite, but we have one difference between this and this. You'll if you know the answer for this, what is the difference between these two infinite sets? Both are infinite, but what is the difference? If you know the answer, you can comment in the comment section below. We'll see the answer in our next video. Thank you. If you have any doubts, you can comment in the comment section below. Inshallah, we'll see in the upcoming video some more concepts. Thank you. If you like this video, please like, share and subscribe with your friends. Thank you.